Greetings everyone. Today we're going to explore writing an inequality in words and determining if a value is a solution. We do have a foldable for this, so you'll want to make sure you have access to that. To begin, this first part is not on your notes, but I want to just go over the idea of flipping an inequality. So you don't need to jot this down, but we do need to make sure to understand it. If I tell you that z is less than 4, and I want to flip-flop that. If I flip the letter and the number, I also need to flip the symbol. One way to remember this is if I'm pointing to the z, then I need to stay pointing to the z. Let's try that again. If I'm pointing to the -2, then I want to stay pointing to the -2. We want to be comfortable with flip-flopping our inequalities. Based on our previous lesson, remembering our symbols and how to read them, we have less than, we have greater than, we have less than or equal to, and greater than or equal to. Let's start off by giving a sentence, and we want to write it in symbols. So if I read the sentence, x is less than or equal to 8, I want to write it in symbols. So let's start with an x is less than. Less than means it's going to point left. Less than or equal to means I have a bar underneath it. And what are we less than or equal to? 8. Let's try a tougher one. 5 less than y is greater than 10. Now that's confusing because it sounds like I have two symbols. So how do I know which one is my symbol? We'll only have one of these in this lesson. So the determining word is the word is. Remember how is by itself means equals? That's going to decide which one is my inequality symbol. Is greater than. All right, so let's decide the rest. Is greater than 10. I can fill that in a little easier. 5 less than y. That means this particular less than is an operation. Is it adding, subtracting, multiplying, or dividing? Less than means subtracting. And remember, when we use less than as subtracting, we have to flip it around. 5 less than y. So we have an expression. So you're going to see words like less than, more than, addition, quotient, product. We're bringing back all of that vocabulary from the beginning of the year. Now let's change the idea. Given the letters, numbers, and symbols, let's write a sentence. So I see a variable b first. So a number b. Remember how we wrote that in front of our variables at the beginning of the year? We're just saying what is b? It's representing a number. A number b is greater than, we have to read that symbol correctly, is greater than what? 9. Now you can write 9 as a digit or as a word. Let's try again. Now, I actually want to flip-flop this one. We want to try to get in the habit of the letter first. So let's change this. We're going to write the H, then the 16. If I'm pointing to the 16, I stay pointing to the 16. So I'm actually going to write my inequality for this expression. A number H, because that's what H represents, is, let's read that symbol, greater than, T-H-A-N, or equal to, that's what that line underneath means, greater than or equal to what value? 16. Now here's the thing, if you're struggling with writing the sentences, just look somewhere else on your task or your assignment or your notes, because I'm always going to pair these two ideas together. Words to symbols, symbols to words. The last topic we want to try is determining if a number is a solution, meaning I'm going to plug 2 in for y, and I'm going to simplify it. So let's try that. That means we have 3 plus 5 less than 20, but instead of y, I'm going to put in a 2. Well, what am I doing to the 3 and the y? I'm multiplying. So I'm also going to put a dot in there so it looks correct. Well, let's simplify. What is 3 times 2? 6. What is 6 plus 5? 11. Is 11 less than 20? Yes, that's good. So what I want you to do is to circle, write yes or write true, but make it really obvious that 2 is good. 2 works. Let's try again. This time with 0. We're going to use the same expression, the same inequality, but instead of y, we're going to replace it with a 0. Let's simplify. 3 times 0 is 0. 0 plus 5 is 5. Is 5 less than 20? Yes, that's good. 0 works. Let's try one more time, this time with 5. 3 plus 5 less than 20, carry all that down, but now this time instead of y we're going to put times 5. Let's simplify. 3 times 5 is 15. Everything else falls down. 15 plus 5 is 20. Ooh, it's kind of a tougher one. Is 20 less than 20? No, it's not. It's equal to. So that statement's not good. So go cross off the 5. It's not good. It is not a solution. Let's try the same process with a different inequality and 3 different numbers. So here's one thing you can do. Since you're going to have to show work, you could rewrite this 3 times. Right? Because we're going to plug in 3 different numbers for x. And I'm going to fill in -1. I'm going to fill in 8. And I'm going to fill in 10. And let's calculate. 2 times -1 is -2. I'm going to drop everything down. -2 minus 4 is -6. Is -6 greater than 10? And you can even go back to elementary school. Am I eating the bigger number? Remember that analogy in elementary school? No, I'm not. So let's put a slash. Let's say no. Let's cross off -1. It's no good. Let's try 8. 2 times 8 is 16. Remember, we're using PEMDAS. 16 minus 4 is 12. Is 12 greater than 10? Yes. So that means 8 is good. We want to keep it. We want to say yes or true. Let's try one more. 2 times 10 is 20. 20 minus 4 is 16. Is 16 greater than 10? Yes, true. That's good. 10 is a solution. We want to keep it. Alrighty, let's take a look at this last one here. This time I want you to find 3 numbers that would make this inequality true. It's almost like you're making the question. So we want to find some numbers that create an expression greater than 3. Greater than, meaning I need maybe a big number. Let's try 10. 10 minus 2 is 8. Is 8 greater than 3? Yes. So one of my options is saying 10. Let's try another one. I'm going to try a bigger number. How about 20? 20 minus 2 is 18. 18 is greater than 3. So another option is to say 20, which means larger numbers will work. But I need a third number. I'm just going to try a smaller one. How about 6? 6 minus 2 is 4. Is 4 greater than 3? It is. So that means 6 is also a positive or a true solution. So keep in mind, I didn't tell you the range of numbers. You could pick large numbers like 50 million, and it would be correct. All right, so now that we've got those notes filled out, make sure you check Google Classroom to see what the task is for today. Make sure you ask questions. If you need help, check out the Sabre Center in B202. And until next time, have a good one.